Okay, so in question 8, June 2005, C4, you can see that the water is being poured into the container at a rate of 20 cubic centimeters per second, right? And it's also losing some volume, and that loss is proportional to the volume. And you might remember from year 10 when you learned about proportionality, you swap the proportionality sign with equals k, but because it's a loss, you're going to call it minus kV. So we are losing volume in proportion to the volume. So the Fisher sign replaced with equals k and a minus because it's a loss. That means that the rate of change of the volume is the increase take away the loss. This is how we get those first couple of marks. Then what we've got to do is we have to solve this using the separating variables method. And you can see here, the most important thing is you realise you can't add or subtract. When you're moving things to left and right, you can only cross multiply. Okay, so you can't do plus kV. You've got to move the whole of this over, and we can only do this with a division. And that's what happens here. And so there's no t's at all, so I introduce the 1. And so on the right I obviously get t plus c. On the left, okay, we've got 1 over something, and this thing's linear, okay, so you get the ln thing. But if I differentiate ln, I get 1 over that, but I'll have to catch the minus k that drops out, okay, from the chain rule. And so that's why I've introduced this fraction here. And then I've multiplied everything by minus k. And so this gets rid of it over here, and here I get minus kt. Now some random number multiplied by some other random number is just another random number. So I don't write minus kc here. There is, with these questions, a little bit of thinking to be done with regard to the constant of integration. Okay, so now I've got this. I'm now going to e everything, okay, and this gives me all of that getting e'd. Now you might remember the two complications with this is when we end up with a constant in the e, we call it a, because it can be written as e minus kt times, okay, e to the c, and this thing gets called a, right? Now it's confusing because in the question they use a and b, and the a in the question is not this a here. This is just what I use and what most people use, a standard form of making this the constant. And you might remember the ln k with the situation where everything's ln and you've got the c by itself. You call it ln k. So don't confuse the a and b that's in the question with this particular a here. Right, now I try and make v the subject, so what I do is I stick this one over here and this one over here, and I divide everything through by k, and you'll notice that here I don't have a over k, I just have a, right? Because as before, okay, when I multiplied this c by k, I just left it at c because it's just some random constant. And likewise here, when I've times everything by where am I? When I've divided everything by k, I've left the random constant, just a random constant. Okay. Now they told me right at the beginning of the question that the volume is 0 when time is 0. Now this means that I get e to the 0, which gives you just 1, and so I'm able to identify that this a, again, it's not the a in the question, it's my a for being in front of e, is 20 over k, and so I can then finally rewrite this thing here as 20 over k, and I've got the final answer. And this is what they're calling a in the question, and this is what they're calling b in the question. Okay. Now, when I looked at the mark scheme, basically that was their finished answer. Okay, and so you're basically just solving the the differential equation, and because they give you some boundary conditions, you're able to work out what the constant is. Okay. Now they tell you that dVdt equals 10 when t equals 5 for the last part of the question, and you can see that dVdt actually doesn't have any t's in the equation, right? What it does have is a v. So what I do is I put t equal to 5 into the equation I've just created, yeah, and you can see I've swapped out the t for 5, okay, and then this is my expression in terms of k for the volume, which I put in the original equation here. I then swapped out the dVdt for the 10 and solved the equation, and using my e's and lun's figured out that k must be a fifth ln t. That allows me to replace in this equation here, which we worked out previously, that k is now a fifth ln t, and you can see me do that there. 20 divided by a fifth is 100, and I just substitute in here, then they tell me that t is 10, and shove the numbers in the calculator, I get v is 108.